When it comes to electric brewing, the heating element options have pretty much been the ripple element and the folded back element. Recently, I got a different style of element in the brew house, and that is the BRewBuilt.
Some folks call it a SlingBlade.
I'm going to put this thing through its paces, let you know how it performs, let you know what the pros and cons are, and tell you who I think it's for. Now, the BRewBuilt SlingBlade element has been around on the market for a couple years. I have been kind of curious about it, and I haven't seen a whole lot of information, not really any reviews. I looked up online, I couldn't find anything about it. There are some reviews on Morebeer where it's sold at, and everybody seems to like it. So I thought, you know what, I'd like to test it out and see how it works. So I reached out to BRewBuilt, and they were gracious enough to send me one. And I'm going to run through everything on this, and I will leave chapter links down below so you can jump through the video because it may wind up being a little bit longer. But I wanted to try to cover everything that I possibly could. I posted a couple photos out on social media, had a lot of questions and some comments. So I want to try to cover everything that you guys asked for and that you asked me questions about. So let's jump into it. All right, starting off with the similarities, the ripple element and the SlingBlade element both have a 1.5 inch Triclamp fitting for mounting, and they also have a L630P plug connection. As far as the size of the elements go, they're pretty much the same. I think the ripple element measured like 14 inches from the base of the Triclamp out to the end of the element. The BRewBuilt SlingBlade, it was a little bit less than that. It was about 13.75 inches, something like that. I had a little cause for concern when I asked them to send me one because the kettle that I'm using is about 13.5 inches in diameter. But with the weldless Triclamp that I'm using, the weldless Triclamp fitting that I'm using, it actually spaced it out just enough where it fits almost perfectly, like it was made for that size of kettle. Now, as far as the ripple element goes, it does fit, but I actually had to buy like a 1 3/4 inch spool in order to get it to fit, because without that, it was actually hitting on the kettle on the inside. So that's just another thing to be aware of, and another added cost to using that size of an element in this size of a system. Now, where the two elements kind of diverge is in the wattage. According to the information on Morebeer, there are several different wattages, the lowest being 3,750 watts, which is the one that I have. Then there's one that's 4,000 watts and on up. What I want to find out is, how does that compare to the 5,500 watt ripple element? So one of the first things that I wanted to do was I wanted to see how quickly the 3,750 watt element would heat up as compared to the 5,500 watt element. So it's an 11-gallon kettle. I filled it with 7 gallons of water. What I wanted to do was see how it would heat up from groundwater temperature all the way up to mash-in temperature, which usually is about 160 degrees. It's kind of a good happy medium. So what I did was I filled the kettle up with the cold water, hooked everything up, and set the temperature controller. I'm using the Blickman Power Commander. I set the temperature controller on 170 degrees, and the reason why I did that was so that as the temperature ramped up, once it started getting close to that mash temperature, I didn't want the PID to start cycling to try to not overshoot the temperature. So I wanted to see just raw power, how fast it could get to a certain temperature. So the results were pretty interesting. On the 5,500 watt ripple element, it got to 160. I actually missed it because I was off doing some other things and it heated up pretty quickly. But basically, I did a little bit of math on it, and the 5,500 watt element heated up 7 gallons of water at basically 5 degrees per minute. So you can expect like a 5-degree rise with this system. Of course, your results may vary depending on what type of system you have. The BRewBuilt SlingBlade provides a little bit less power at 3,750 watts, but it was still a respectable half hour basically to heat up to that 160 degrees. And based on the math that I did on that, we're looking at about 3.5 degree per minute rise on the SlingBlade element. If you've enjoyed this video so far, leave a like down below. It certainly does help with the YouTube algorithm. We certainly do appreciate that. Now, the next test that I wanted to perform was, how did the elements in the system hold the temperature whenever it reached that 170 degrees. In the case of the ripple element, it did an okay job, but it did do a little bit of overshooting, and then it had quite a bit of fluctuation in the temperature. Now, one of the things about the system, the way that I built it, and I think a lot of manufacturers could do this and have a little better performance, I have the temperature probe and the outlet of the kettle or the dip tube right next to each other in relation. And the way that this SlingBlade fits in that configuration is actually pretty slick, because I can put it right underneath of the temperature sensor. as well as right behind the dip tube. So basically the liquid that's being heated is right in proximity to the sensor. And so that's going to help prevent overshooting, as you're seeing here. I'm not so worried about not hitting the exact temperature, but if you look at the fluctuations of the temperature once it reaches that 170 degrees, are pretty impressive. I mean, it only varies by a few degrees whenever it hits that temperature point. So after I did those 30-minute time-lapse tests, I wanted to see, okay, how fast will both of these elements come to a boil from 170 degrees? So if you do a 170 degree mash out, you're going to be at that temperature already. So how long will it take to get from that temperature to boil? And the 5500 watt element began to boil somewhere around 8 minutes after I reached that 170 degrees. The BrewBuilt element reached it a little bit later at about 14 minutes. And one of the other things that I was kind of interested in, they do kind of tout that it has a better boil or more of a rolling boil. And I will tell you that I am pretty impressed with the boil on the BrewBuilt element. Because of the way that it sits in the kettle, there's a little bit of convection that goes on. So basically it heats from one side, and then as it heats up, it creates a little bit of motion, or there's some rolling of the water off of the element, the bubbles and everything. And it does create a really nice rolling boil. I was able to get 7 gallons up to a boil pretty easily, and then I actually turned it down to, I think it was 70%, and had a really nice rolling boil. Now the Ripple element obviously will boil harder because it is a higher wattage element, but as you can see, it has just like a weird, just random boil almost. The next thing I wanted to test was how did the elements do in like a real world scenario where you were doing like a mash with the recirculation. So I set up the kettle to be just like it would be if I was doing a mash. I put the basket in, I put the bag in, I put my recirculation arm in there and started the recirculation. And I wanted to try to mimic an actual recirculation speed. So as you can see here, I've got a pretty low flow. I didn't want to have a real hard continuous flow because quite frankly, I feel like if you have a hard continuous flow, the system should maintain the temperature pretty easily. But where you might run into issues is if you're slowing down the flow, not letting the grain bed get compacted and stuff like that. So what I did was I slowed it down and then just let the system run. I did a 30-minute time lapse on that as well. As you can see, I let the system come up to temperature, like as if I was bringing it up to that mash temperature, and then just did a 30-minute time lapse to see how it did. As you notice, the Ripple element did actually overshoot by a few degrees, and then it came back and it just kind of bounced all around everywhere. And I feel like that is what contributes to that is the fact that the element is kind of in the center of the kettle. And so as everything is flowing through, the temperature probe is not reading the exact temperature fluctuations off of the element. Now with the BrewBuilt element, it definitely was a lot tighter of a window as far as accuracy goes. It did overshoot slightly when it got to 152 degrees, but then it seemed like it really maintained the temperature very well. The other part that I wanted to test was, okay, I know what the liquid is in the base of the kettle. What's the temperature when it comes back up to the top? The 5500 watt element, it did a pretty good job, but there was a little bit of variation there. I did notice, however, with the SlingBlade element, that after measuring at like 20 minutes into the mash period, the 30 minutes that I tested them for, the SlingBlade element actually had a much more accurate temperature reading at the top versus what it was reading at the sensor. So there wasn't a whole lot of differential from the bottom of the kettle to the top of the outlet off of the recirculation port. One of the other questions that I got whenever I posted the photos were, how does it affect a whirlpool, or does it affect a whirlpool at all? So what I did was I had some old hops, and so I just chucked them into water. Tip on that, don't put cold hops or frozen hops in cold water. It was a horrible idea. Clogged up the dip tube, clogged up my pump, all that stuff. The other thing that was kind of weird too was I have a real high iron content in my water here. I have well water. And the hops and the oxidation and everything turned the water kind of orange. So if you see orange colored water, that's what it's from. It's not actual wort. It's just hops and water. But so what I did was took the both elements, filled the kettle with the same amount of liquid. It was about 6 gallons if I remember correctly. Whirlpooled for like 15 minutes and then turned everything off, turned the pump off, let it sit and settle down until the water wasn't moving any longer. And then basically drained the kettle to see what the whirlpool or the hop cone looked like. I could see just a little bit of a difference with the Ripple element as opposed to the SlingBlade element. I do think that the SlingBlade element being out of the way of that whirlpool in the middle did give it a little bit tighter cone, a little bit tighter hop mound, if you will. I think the ripple element kind of provides a little bit of turbulence, and the hop residue actually kind of spread out a little bit, whereas with the ripple element, I think the pile was a little bit tighter. So that's how it performed on the Whirlpool. Now let's talk about price on these. And one of the things that I wanted to kind of highlight on this in the price is that the elements are not the full story. And I'll explain. The 5500 watt ripple element you can get for anywhere between probably $59 and $69. The BRewBuilt SlingBlade element, the 3750 watt element, it actually retails for $99 on Morebeer. And so, I mean, you might say, okay, well, that's, there's a pretty big price difference there until you look at the whole picture. And the whole picture is, with a 3750 watt element, you can actually power this with a 20 amp inline GFCI. Now, I've done some videos on making one of those for all-in-one systems, but you could actually use that exact same GFCI inline to run the Brew Commander and this element and not have a problem at all. So what does that mean? You could build that adapter or build that GFCI cord for just under $130. And with the 5500 watt element, you need at least 30 amps in order to be able to run it. So what does that mean? That means you've got to put in a 30 amp GFCI, run wires, do all that sort of thing. And most of the GFCI breakers are somewhere between $100 and $150 just by themselves, without installation, without wiring, without outlets, without anything like that. So basically, if a person is in like a rental or an apartment building or something like that where they can't add any kind of circuits, this SlingBlade element certainly is an excellent option to get into electric brewing, either converting your current kettle that you already have or building a new system, much like what I did, and being able to power it without doing any kind of modifications. You can plug it into either the power for your stove, or you could plug it into the power for your dryer, depending on how new the electricity is in the residence that you're living in. The other advantage to the BRewBuilt SlingBlade element is that you can use an immersion chiller in your kettle. It doesn't get in the way like a ripple element does. And I would be willing to bet, leave me a comment down below, what is the chiller you're using now? And I guess what was the first chiller that you bought? I know most people, when they go from dropping the kettle into the sink with, ice cubes or whatever, most people are going with an immersion chiller. I have a jaded chiller and it works perfectly with this situation. I mean, it can fit right in the kettle, whereas if I'm using the ripple element, it won't fit in there without some extra devices. The other thing I wanted to talk about was customer service. I haven't had a lot of dealings with BRewBuilt as far as customer service goes, but when I received the element from them, I did notice that there was a little bit of some kind of a clear, looked like epoxy on it. I think it might have been from the potting of the power end of the element. On there's a plastic housing, and generally when they make the connections, they fill that up with epoxy, and it looks like maybe somewhere in the manufacturing process, it may have dripped some epoxy onto the element. Contacted them, sent them some photos. They're like, nope, shouldn't have passed QC like that. We're going to send you another element right now. So I don't know that situation could have been handled any better. So I feel pretty confident about how they're going to handle things in the future with my viewers. So my thoughts on this are that it's definitely a viable option. The 3750 watt element that I'm using in this system is more than adequate enough for 5-gallon batches and an 11-gallon kettle like I'm using it. They do offer a 4000 watt model, which is the next step up. And that certainly is enough power to do 10-gallon batches and whatnot. And it will also run off of that same 20 amp GFCI cord. I know a lot of people are going to go, oh, you're over 80%, but 80% is only applied to things that run continuously for 3 hours. And most of the time, I don't know of a time that I've ever run a brewing system at 100% for 3 hours. So that's really not an issue. It draws a little bit, somewhere around 18 3/4 amps at 4,000 watts. So it's not overtaxing your system by any means. Leave me a comment down below and let me know if you'd like to see a complete video on the system that I use this in. I think it would be an awesome apartment or rental brewing system. I kind of hinted about that in some surveys I did recently. So leave me a comment down below. Let me know if you'd like to see a complete how-to on the system that I'm using here. And if I get enough comments, I'll do it. If you found the video helpful, certainly give us a like. We certainly appreciate that. Thanks again to everybody that has watched and subscribed. This has been Brian for Short Circuited Brewers. We'll see you on the next video.